Now we begin our CSE for 20's final report presentation. Our project tries to detect and classify dog and cat in an image. In this page of slide, it shows the 5 classes of cat and the 5 classes of dog that we studied.
We use histogram-oriented gradients to extract features from small image patches. First, compute horizontal and vertical gradients for each pixel in a patch. Then we create histogram based on the previous computed gradients and group cells together into blocks. Finally, we also need to normalize every block and concatenate them together into a large vector. Then, for positive and negative data, we compute their hog and use these hog features with labels either 1 or 0 to train our SVM. SVM constructs hyperplane in the height dimension to separate vectors apart. Based on their labels, we first normalize the data and then feed them into our SVM model. With our trained SVM, we can apply a sliding window to detect dogs and cats in given image. First construct a window and then slice it through the image and compute its hog features. Then we will pass our features to our trained SVM. If it predicts positive, then we'll draw a rectangle of the window since it indicates that there is a dog or cat. We can also group the rectangles into a bounding box if the rectangles are overlapped.
In the CM part, it includes 4 steps. First is convolution, and most of CM model consists of some convolution layers. Second is nonlinearity. The next is max pooling, which is downsampling and input representation. Last is the classification step, which is using our trained CM model to classify an object. Now let's introduce general pipeline of our project according to the pipeline image shown in the slide. First of all, we train our hog model, get the feature vectors. Similarly, we train our SVM and CM model. Then we use sliding window together with hog to extract the feature vectors from the sub-region. Along with our trained SVM, we can extract the object inside the rectangle and put it into our trained CM model. And the final output is the category of our detected object.
Here are 2 test images. Okay, so due to time limit, we trained our model before using this piece of code, and we reloaded the model from the Pico file as the small VGG classifier. Now we run our main program. As you see, the first image is classified correct, and the second one is also correct. Thank you for watching this.
Here is our detection result. The first column of the table is the result before grouping. You can see that there may be multiple rectangles. The second column is the result after grouping rectangles all together. And the third column contains the object that will be passed to our trained CNN for classification.
In this page, we show the accuracy and loss rate when we train our modified version of a CM model with our dataset. The training data from our CM model show that the final accuracy rate approaches 85%, the final loss rate approaches 35%. Finally, we can classify the object we have detected, and on this slide, we show the final result when we run our project. Here we can see that the first 2 dogs are correctly classified, as well as the third cat, but the last cat we have a false positive, since this should be a Bombay, but we consider it as a Rush Blue.
Before I started my detection, I searched online and found the following link. In this link, it tries to detect the faces of cats using OpenCV's Cascade classifier. It is more accurate on detecting faces, but our method will detect the whole object instead of just face.
In the CM part, we use the open source code of CM from Keras buildings. However, this buildings method just provides some high-level structure of the CM model. In order to construct our own CM model, adjust the parameter and some convolutional and dense layers.
The first topic covered is hog. We try different parameters on that. The second topic is SVM, together with positive and negative dataset to train the model. For this part, I've tried different implementation and parameters of SVM.
I combined Keras VGG60 models with Keras Optimizer SGD together to construct our own CM model.
I constructed the hog descriptor. Then I build, train, and compare SVMs of different parameter settings. For the end of the detection part, I also implement a sliding window to detect and extract object, with an option to perform a grouping operation on all detected rectangles.
I construct a CM model to train multiple kinds of model and find the positive and negative data for training the SVM.
That's the end of our presentation. Thank you for watching this.